Hi there, this is Karishma from BlobCity. I'll be your host for today. Thank you all for being here. We have people joining us from across the globe. So, good morning, good afternoon, and good evening to all of you. Good to know the massive turnout. Your enthusiasm always keeps us motivated. Today, we have a fantastic lineup of speakers to talk about using blockchain for wastewater recycling. It's always amazing to see how technology can solve real world problems. Use the questions dialog on the side panel to ask any questions that you may have. For the benefit of everyone, the speakers will answer the questions after the main presentation is over. We have kept ample time for Q&A, so please go ahead and ask as many questions as you'd like. We'll all do our best to answer as many questions as we can. This webinar will be recorded, and as an attendee of this webinar, you will receive a copy of the same. The recording may also be made public. So, you eager to get started? Well, I am. So let's get to it. I'd like to welcome our speakers for today, Ajith Radhakrishnan, India Country Coordinator for the 2030 Water Resources Group, which is a part of the World Bank Group. Our second speaker, Mahesh Patankar, also part of the 2030 WRG. And our third speaker, Sanket Sarang, our very own Chief Technology Officer at BlobCity. With this, I'd like to invite our first speaker, Ajith, to start the presentation. Over to you, Ajith.
Thank you, Karishma. I am Ajith Radhakrishnan, a Senior Specialist and Country Coordinator for the 2030 Water Resources Group at the World Bank. I welcome you all once again to the first of a series of webinars that will be rolled out to help you with the Blockchain Hackathon. It is indeed an exciting opportunity to join hands with you and find common solutions to some of our biggest challenges. That includes water scarcity. In the interest of time, let me jump straight into the presentation. But before we start, let me also give you a bird's eye view of the outline that we intend to cover today. Between Sanket, Mahesh, and me, we will help you understand why are we here, what are we trying to solve for, and how are we going about it. But first, for the participants who would not have heard of the 2030 Water Resources Group, let me begin with a quick introduction. The 2030 Water Resources Group, or the 2030 WRG, is a unique public-private civil society collaboration. We facilitate open, trust-based dialogue processes to drive action on water reforms in water-stressed countries. The ultimate aim of such reforms and actions is to close the gap between water demand and supply by the year 2030. Our global partners include a variety of organizations and governments and bilateral agencies. And this initiative was launched in 2008 at the World Economic Forum and has been hosted by the World Bank Group since 2012. True to the spirit of this collaborative action, openness, and dialogue processes that we just talked about is this Blockchain Hackathon initiative, where we are partnering with the Maharashtra Water Resources Regulatory Authority, the MWRRA, and the Bombay Chamber of Commerce and Industries, BCCI, and you, through our able technology partners BlobCity, to solve for some of the water sector challenges that the government of Maharashtra faces today. In the first of the three slides that I have for you today, you can see some big numbers, and that will help you understand the magnitude of challenges that we face. You can see that around 80% of India's water is used for irrigation, whereas 2/3 of irrigation needs are also met through groundwater, and that has led to over 60% of India's districts facing groundwater crisis. The situation is no different in the urban areas as well. You can see that only 2% of urban areas have both sewerage systems and sewage treatment plants. 40 billion liters of sewage is generated daily, and only 20% of that is treated. All these numbers point out to a dark reality. It says that we have issues on both the demand and supply side, and we need unconventional thinking and probably collective action to back that up for solutions that can take us forward. The second slide gives you a snapshot of an analysis. This analysis projects a 50% gap between water demand and supply by the year 2030 in India. To close this gap, the government would need an investment around 6 billion US dollars. And this investment needs to happen in multiple sectors. As you see here, it includes agriculture, irrigation, infrastructure, manufacturing and services, and urban development. It also gives you a powerful message. It highlights the need to work across sectors. It highlights the need to look at unconventional opportunities. It also talks about the need to look at synergies between different sectors and industries. That has been the dominant narrative that 2030 WRG has been trying to advance in India. By working with the state governments and the national government, the 2030 Water Resource Group of the World Bank is trying to push for innovations that will help solve some of these challenges. 2030 WRG works with 3 large state governments in India, which includes Uttar Pradesh, Maharashtra, and Karnataka. In each of these 3 states, we have set up multi-stakeholder platforms that comprise of the government, the public, private industries, the civil society and academia, and eminent thought leaders. Together, these multi-stakeholder platforms are driving innovations and helping the state governments to address the water scarcity issues in the state. It also works at the national level in India on priority topics with the Government of India through its Ministry of Water Resources. In the last slide that I have for you, I would like to give you a snapshot of the 2030 WRG state engagements and the thematic priorities. In the states where we work with the governments to identify the thematic priorities. And this includes the setting up of multi-stakeholder platforms because collaborative action is the essence of finding innovative solutions. And in addition to that, through these multi-stakeholder platforms, we help the government identify the thematic priority areas, the thrust areas where the government will be able to generate maximum impacts through its investments, and also address the priorities that the government's policies have targeted. So you can see that in Maharashtra, there is a robust multi-stakeholder platform which is chaired by the highest ranking bureaucrat, the chief secretary, and with the support of all the secretaries of various line departments including agriculture, horticulture, and irrigation. The government runs the multi-stakeholder platforms with the help of various private sector players and the civil society and academia. It has identified that urban and industrial water use is a challenge that needs to be addressed, along with the need to provide water in the command areas where large irrigation investments have happened. So there needs to be increases in efficiency for the farmers to get more crop per drop, and also to help the rain-fed areas where small and marginal farmers are grappling with water scarcity that is a result of various challenges including climate change. In Karnataka, again another large industrialized state, the focus has been on urban and industrial water use and similarly on command area water productivity. In Uttar Pradesh, you can see that the state government has, in addition to operationalizing the multi-stakeholder platforms, also identified tributary management of the Ganges River as one of its priority areas. So cleaning the tributaries is the answer and solution for a cleaner Ganga is a message that comes out of this engagement. Similarly, in some of the poorest and drought-stricken areas of Bundelkhand, the 2030 WRG is helping the state government address water scarcity challenges and trying to take the discussion forward of fostering more innovation and collaborative action. I would leave these slides with you and the important message of collaborative action and innovative thinking to find solutions in water sector. Business as usual is not going to be the norm any longer, and we would need to build creative and innovative solutions to address this. And I request your help and support to help us solve some of these challenges that Mahesh would be presenting from Maharashtra, and to also work with us and the government to address the development challenges that we face as a collective. Thank you.
It is well established that water security is important in different aspects of economy. Specifically related to the wastewater treatment, there are several conventional financing options that are used. Typically, project financing using state budgets for the capital expenditure is a norm, and the urban local bodies and the municipal corporations typically meet the operational expenses that are financed through a cess that is collected on water. But the entire world is moving towards some kind of market-based instruments. So let's call those as economic instruments. And one of the key principles under the economic instruments is price put on the pollution, which means the polluter pays principle needs to be applied. Even the UN Water, which is one of the leading agencies, recognizes several mechanisms such as prices or tradable permit systems related to the water treatment and the wastewater treatment. Based on this, our group, we came up with a concept called as Wastewater Reuse Certificates, which is supposed to be an economic instrument which is tradable and is applied in different kind of contexts. 4 business cases, or let's call those as case scenarios, that we think that are applicable when we talk about wastewater recycling opportunities include the following. First and foremost is large industries and the industrial parks, which use a lot of fresh water, and if you can do something about reducing their freshwater intake by insisting on them recycling wastewater into their processes, that's a very important opportunity. Second aspect is urban local bodies and municipal councils, such as large municipal corporations, say in North India, South India, in Maharashtra, corporations such as Nasik, Pune, Nagpur, so on and so forth, some kind of wastewater recycling target put on them. The third aspect is several types of gated communities and the housing complexes, which also use a lot of water for gardening purposes. They also use water for car washing, so on and so forth. And last and most important part being urban wastewater treated and used in the agriculture, which would meet the food standards, is again an important aspect. So there are several types of incentives that one can offer if you can manage compliance of the 4 case scenarios that I just talked about, which include if you are meeting the targets, you would get certain reduction in your tariff that you pay to the bulk water supplier. Secondly, the wastewater reuse certificates can be traded as a commodity to offset bulk water tariffs itself. And lastly, any kind of higher allocation for general tax collections that the urban local bodies can get from the central government and from the state government is another important aspect. Now let's look at how this kind of mechanics would work. So the structure of the trading mechanism for the wastewater recycle would work as follows. We would have some kind of a current mandate. Let's assume that the regulators in the water authorities are imposing a target of something like, say, 20% on all the industries, industrial parks, urban local bodies, so on and so forth. The next phase is basically a regulator such as Maharashtra Water Resources Regulatory Authority can impose certain higher targets. They can say that thou shalt recycle nothing less than 35% of water. And then based on those targets, there are several industrial parks and the urban local bodies would achieve or achieve their targets. Some of them would underachieve the targets, some of them would exceed the targets. Now those who exceed the targets can potentially trade those wastewater reuse certificates with those who do not meet those targets. And that's exactly the fundamental of any sort of tradable permit or the trading mechanism that one can think of. So during the coming 4 slides, I'll describe the 4 case scenarios that we talked about, which again include industries, urban local bodies, gated communities, and agriculture sector. So pertaining to the large industries and industrial parks, let's imagine they have X fresh water intake, say X meter cube per day of fresh water intake. They are obviously generating certain wastewater. We call that as A. A is nothing else but volume, and that goes into some kind of a wastewater treatment plant. After the wastewater treatment plant, they're supposed to discharge it into the environment, meeting the regulated environmental standards, which are specified by the likes of Central Pollution Control Board and the Maharashtra Pollution Control Board. What we are suggesting here is that some of that should get recycled back into the processes, either in the individual industries or the entire industrial park, and let's call that as volume B. So the target that would get set up is nothing else but a fraction of B over A, which means if I'm recycling say 10% of the wastewater that gets treated in the existing wastewater treatment plant, if I can do anything further than that by providing additional polishing treatment, it would get recycled back into the process. So that's the fundamental related to the large industries and industrial parks. Let's see how would it play out if we talk about urban local bodies and the municipal councils. So again, the municipal councils are generating wastewater from different housing complexes and so on. Let's call that as a volume A. Again, that gets treated in some kind of a central wastewater treatment facility, and if they meet the standards, it would get discharged into the environment. Any kind of target such as say B meter cube per day out of the total generation of A meter cube per day, if it gets recycled back into the agriculture sector or the industrial sector, or also within the urban local bodies and the municipal councils, that would be again an example of the target met. And again, in this case, B over A is the percentage target that we are talking about. Let's move on to the housing complexes and the gated communities. Again, a similar principle where the freshwater intake happens, the sewage gets generated, which is the wastewater coming from the housing complexes and the gated communities. They have an existing sewage treatment plant which meets to the standards set up by the pollution control boards. And if you can do any further pollution treatment, and if you can bring it back either into the housing complexes or back into the agriculture sector or back into the industrial sector, the quantum B which would get recycled is nothing else but the target met, and again in this case the target would be B over A. In case of the agriculture flows, let's imagine an agricultural land. Let's assume it's growing maize or sugarcane, and you require certain meter cube per year of water to grow that crop, and let's call that as AG, and we are denoting that as AG. And if this particular agricultural land uses the recycled water or recycled wastewater coming either from the industries or from the urban local bodies or from the gated communities, we are then talking about specific targets met, and in this case as well the target would be B over AG. I would now like to pass on the presentation to Sanket to explain some of the technical aspects of how wastewater reuse certificates and blockchain can be used to track and enforce reuse of wastewater. Over to you, Sanket. Thank you.
Thank you, Mahesh. Good to see you all here. There's so many of you at this event. I'm Sanket from BlobCity, and I'll be talking a brief about how WRCs are actually implemented onto the blockchain system. So we're looking at a system that comprises of 5 major components. The first being IoT meters that capture data from the field and report it to some curation service. These IoT meters could use well-known protocols such as MQTT. It may even report data over FTP or any other protocol that the meter implements. The meter could be an Arduino device, a Raspberry Pi device, or it could be any other embedded chip or any microcontroller that is basically used in the field. The purpose of the meters is basically to capture volume of water and also certain quality of the water, certain parameters that tell us about the quality of the water. Data coming from these meters goes to the curation service, which looks at the data. It identifies if the data is coming from a legitimate meter or not, and whether to accept this data or not, depending on the meter from which it is coming. There is a management portal that is provided to the authorities, which includes the water regulators and several other contracted companies that are responsible for running the service. And the management portal is also used for registering new meters, registering new organizations, and stuff like that. It also gets an oversight of how many meters are actually reporting data, and the management portal can be used to send alerts to companies when the meters stop reporting data for any reason. This data that comes in through the meters is written directly onto a blockchain by the curation service. We are mandating that all data points reported by meter go onto the blockchain. Even if we think the data point is fraudulent, it will go onto the blockchain. The curation service may use certain amount of machine learning, or there may be post-facto machine learning after data has gone into the blockchain to see if any tampering has been done with in the meter. There could be certain machine learning models used to do anomaly detection, and using these anomalies, one could basically find out if there's any type of data reporting fraud that's happening. But at all points in time, data is stored into the blockchain. There could be additional data points stored into the blockchain that tells the system which data points or which meter data readings to accept and which to not accept. The data that's now in the blockchain is then used to issue the wastewater reuse certificates, which are also then registered onto the blockchain. The wastewater reuse certificates are issued on multiple complex formulas, and that require a certain minimum quality of water in the reuse process and a minimum quantity of water. So it's not actually minimum quantity, but based on the quantity of water you reuse, you get WRCs for it. But there is a certain minimum amount of percentage of recycling that you reuse, rather, that you need to do in an entire financial year. And if you don't meet this percentage reuse target, the regulators may penalize you for the difference that you've not achieved. This is very related to what Mahesh spoke in his previous slides, explaining some of the underachieved and overachieved targets and regulator targets. So the volumes of water reused equals the number of WRCs you earn. The regulator already knows how large a manufacturing plant or how large a housing complex you are. So the volumetric target is set by the regulator, and the water targets for quality are set based on the specific use of water that's happening. Then once this data is in the blockchain, there is a reporting and analytics dashboard that allows viewing of this data in the blockchain in a human-friendly manner. The blockchain is, of course, a public implementation. It's not a private blockchain. We encourage that this data be in the hands of the public, at least in the hands of the corporates who are part of this WRC implementation, so that each and every company can actually look at all the WRCs that are issued and can also look at if each corporate is compliant. The identity of each organization does not have to be known. Just the integrity of the whole process needs to be made public by means of the blockchain. Then assuming certain corporates overshoot their WRC targets and some undershoot it, some corporates will be, so there will be a trading platform, a trading system, and it could be run by another regulator who runs the trading system. And the trading system basically involves buying and selling of the WRC certificates, wherein organizations that do not meet their required WRC targets would have to buy the different certificates for a set price by the regulator. The trading part is still in ongoing discussions and conceptualizations. but there is potential for it being implemented, but we're not yet sure how and in what manner would it be implemented. Having explained at a high level how the WRC and the blockchain system works, I'm pleased to let you know that we currently have an ongoing hackathon called the WRC Blockchain Hackathon. It is organized by 2030 WRG, part of the World Bank Group, along with MWRRA, which is the Maharashtra regulator for water, and BCCI, which is Bombay Chamber of Commerce and Industry. And I'm also pleased to let you know that BlobCity is helping these three organizations manage the hackathon from a technology standpoint. The hackathon really strives to bring in innovation in the reference architecture that's explained to see what are the ways in which a real practical implementation of the WRC can be done. We strive that contestants actually do some piece of software development, set up a demonstrable blockchain, and come and present to a panel of jury from both the technology side and the domain side on explaining what would be their recommendation for implementing blockchain into implementation of this WRC. So basically using blockchain for the WRC implementation. You can visit the hackathon website. We are using the DevPost platform for hosting the hackathon. So you can visit it directly at wrc-hackathon.devpost.com. We also have a dedicated website for the hackathon, which is wrc-hackathon.org. Participants must register on the DevPost link to participate and make the submissions through DevPost. The process for submission and a lot of the technical resources, domain resources, are already available on the hackathon portal. So the moment you register, you should have access to a lot of this information to participate in the hackathon. I really encourage everyone to participate in it. The hackathon is currently live, and the last date of submission is 17th of February. It may be 18th of February in few time zones. This is a global event, and we're looking for a massive participation to come with some of the best innovative strategies for using blockchain to facilitate a real-life implementation of WRCs. There is a plan in place to actually work with some of the winning teams to mature their solutions. And we look at the teams making their solutions open source so that it can be globally adopted across a lot of countries and states to implement the WRC concept in the respective geographies to facilitate better use of water. I know there are a lot of students in the audience, as well as we have corporate attendees and even freelancers. I encourage all of you to register and contribute as part of the hackathon. While software coding is essential in the hackathon, it's not necessary that each and every team member know coding. So if you have a concept for WRCs, you have a concept for blockchain, you don't have a coder on your hand, no problem at all. Go ahead, register for the hackathon. There's a system in place to help you find coders who will code your concept. So do find co-team members using the DevPost platform. We have a Slack channel. You can connect with co-participants in the Slack channel, connect with them, form your teams, get all the capabilities that you need in one team, and then make a final submission before the deadline. Okay, so with this, I'm done with my part of the presentation. And I believe we will now be moving on to the much awaited question and answers.